When you are doing a multi-step equation, undo addition and subtraction first, and then you undo the multiplication and division. So, for example, this one is a multi-step equation. Why is it a multi-step equation? What are the two types of operations excuse me, that you see in this equation? There is multiplication happening, and what other operation is happening? Addition is happening. Okay? As soon as there are multiple operations, it's a multi-step equation. And in this one, we have multiplication and addition. The other thing to look at in this problem is this is still relatively simplistic because there is an expression on this side, and this side is a single constant. Okay? The term constant is the term we use when there is a number in an algebraic equation that does not have any variables attached to it. It isn't a variable. It's called a constant because it doesn't change. It stays constant. Okay? And so on each side, we would do this. When we talked about the order in which you solve multi-step, what do we need to do first? Do we need to address the multiplication first, or do we address the addition first? We undo the addition. What property am I going to use to undo the addition? The subtraction property of equality. Okay? So, on this side, I would do what? And why am I doing all these properties? What is my ultimate goal? I am trying to do what? What is the goal? Isolate the variable. Now in this case, there's only a variable on the left. There's nothing on the right. So I automatically know the placement of my variable. My variable is going to be on the left. My solution will be on the right. So I'm going to subtract 3 and subtract 3. So that's what I'm going to isolate. Subtract 3, subtract 3. When I subtract 3 from both sides, I'm going to get 2w equals 6. Because positive 3 minus 3, 0, 9 minus 3, 6. Okay, so that's my one step. Now what operation do I have left? What is the operation that is remaining? And now I can undo the multiplication. And what would I do to undo this multiplication? Division. So I'm going to divide by 2. And this is where you really kind of have to look. And because it's 2, you know it's automatically divided by 2. Most of the problems you're going to get in your book are going to be nice and clean. This will be an even number or divisible by that. So I would divide both sides by 2. W equals 3. And so there's my answer. W equals 3. It can be 1W. It does not have to be 1W. Let's just pre-record it. Yes?
So with the, but do we have the right, like say we are...
We can see here we have two operations. What are the two operations that we see here, Jack? You, Jack. In this one we have multiplication and subtraction. Which operation do we undo first, Sophie? Subtraction. So our next step is going to be doing what? Adding. It's the addition property of equality. We're going to do the opposite. We're going to add 10 to both sides. So there's our variable we're going to isolate. We're going to add 10 to both sides. When we do that, we end up with 3p equals 18. Okay? Yes? Okay, and that's where I think some people get confused. It doesn't matter what you call it. I mean, when you are subtracting 10, essentially, you're adding negative 10, right? Right. So you could say this is 3p plus negative 10, or you could say it's 3p minus 10. You can look at it. When I'm looking at the problem, I say subtract. In my head, I do think of it as negative 10 plus 10 cancel each other out. So yes, that's where I think people get confused. So they're like, well, I'm minusing 10, and I want to get rid of that 10, so I had minus 10 more. Another way you can write these out, and I saw Evan do this. Evan writes it like this. When he does it, he does 3p minus 10 equals 8. In his second one, what I've seen him do is 3p minus 10, and then he does the opposite. Plus 10 equals 8 plus 10. So what I've seen him do is he keeps it all horizontal, and he puts it on the line so you have minus 10 plus 10. And I don't know if that works better for you. It's kind of doing the same thing, but then you don't have to think of that as a negative if you don't want to. Yes?
So what's the negative, or what's the subtraction? What's it, is it like changing the property, or is it changing the subtraction to addition, or is it adding on?
You're adding a 10 to where you're subtracting a 10. So this is minus 10 plus 10. So if you looked at it horizontally, 3p minus 10 plus 10 equals 8 plus 10. So it's kind of doing minus 10 plus 10 where you're canceling them out. Does that make sense? Does that clear it up? Okay. If you want to write it this way, you can. A lot of people do write it this way. Some people write it this way. That's kind of the choice that you have there. All right, we're down to another operation. And what operation is left here, Morgan? Multiplication. And to undo multiplication, we do. And so what would I do to both sides? Divide by 3. And so if I'm going to divide the left side by 3, got p equals 6. Okay? Okay, here we have another one. We have two operations in this one as well. And what are the two operations that are hidden here, Juling? What operations do we have?
Oh, we have divide and we have subtraction.
And which one will we do first?
We're going to add 9 to the...
Well, we're going to undo subtraction by adding 9 to and
negative and 3.
right, to both sides. Remember, what you do to one side, you have to do to both sides. So there's our variable. Our variable is connected to the 4 through division. Going to add 9 to both sides. So we have d divided by 4 equals 12. Okay? So our operation is divide. So what are we going to do to undo our division? I'm going to multiply, and what are we going to multiply both sides by? 4. Now this is where I saw some people have some troubles with it last time. You can look at this as, you could do d divided by 4 and then just times 4 down here and know that they automatically cancel it out. But remember, what you're technically doing is doing d over 4 times 4 over 1. Okay? And then you can cross those two out with the cross cancelization, and you have d over 1. Does that make sense? And that's how you're getting just d by multiplying by 4. So if we do both sides times 4, we have d equals 48.